So this is our fourth and final video on circles. We're going to wrap up the last page of the circle handout. On the last page of the circle handout, we talk about some functions that are related to circles. So let's look at an example. X squared plus y squared equals 25. That should look familiar to you right now as a circle centered at the origin of radius 5. Suppose we isolate y squared in that equation, so we write it as y squared equals 25 minus x squared, and then suppose we solve for y by taking square roots. Y will be equal to plus or minus the square root of 25 minus x squared. Now we cannot take square roots separately here because we're subtracting inside the radical sign. So we can't simplify this further, but we can observe that we have two separate equations. We have y equals the positive square root of 25 minus x squared, and y equals the negative square root of 25 minus x squared. Each of these describes y as a function of x. Each equation has its own graph, which is the graph of a function. Now, a circle is not the graph of a function, but notice that when we solve for y and take these square roots, what happens is it's kind of like we split the circle in half. The positive square root has a graph that's the upper half of the circle, and the negative square root, since y values will always be less than or equal to 0 here for this equation, is the lower half of the circle. So by splitting a circle in half, we can actually obtain half-circle graphs that are graphs of functions. The first has domain, the interval from -5 to 5 with square brackets, endpoints included, and range of y values from 0 to 5. The negative square root has the same domain, x values from -5 to 5, with endpoints included, but notice the range consists of negative y values from -5 to 0 with endpoints included. So let's do a couple exercises where we work with these functions, and again I have the statements of the problems written out by hand here separately. So could you graph f of x equals the square root of 9 minus x squared, and you could think of the general shape. It's very similar to the example given on the handout. We could also try to reason this out a little bit. This is like y equals the square root of 9 minus x squared. If you square both sides, y squared equals the square root of 9 minus x squared squared, or y squared equals 9 minus x squared. Add x squared to both sides, I get x squared plus y squared equals 9. So that's a circle with center at 0, 0 at the origin, of radius, we got to take square root of 9, so radius 3. The difference with this guy is this is just the upper half of the circle, because it's only the positive square root. The y values will always come out to be positive for that square root function. So we can draw a graph. X-axis, y-axis, x and y, and I'm just going to go 1, 2, 3, 1, 2, 3, -3. So the graph of f is going to look like this, just the upper half of a circle with those endpoints included, and I guess I want to give you the domain and the range. Let's see if I can write this off to the side here. Domain is from -3 to 3. endpoints included. The range, because this is a positive square root, the y values will be positive, is from 0 to infinity. I'm sorry, 0 to 3. Ugh. 0 to 3. I don't know where that infinity came from. 0 to 3. And let's look at the next one. Number 11. So in this case, we have, I notice g of x equals, I see a negative square root. That tells me something. And I see this square root of 4 minus x squared. That's related to the equation of a circle. It's like y equals negative square root of 4 minus x squared. If I square both sides of that, even with the minus sign, I get y squared equals, so a negative times a negative would be positive. Square root sign goes away. 4 minus x squared. Add x squared to both sides. And so I get x squared plus y squared equals 4. Now, this equation is a circle centered at 0, 0. Of radius, the square root of 4, which is 2. Now, the difference, though, is this function g is just the lower half of the circle. So when we write the equation in x and y and square both sides, what happens is squaring both sides changes the equation, changes the information. It's still a good guide for us to understand where we're coming from, but as soon as we square both sides, we lose the fact that the original function was just the upper half in number 10, and we lose the information that the original function was just the lower half of the circle in number 11. So you got to recognize that right at the beginning, because this x squared plus y squared equals 4 is not equivalent, but it does certainly guide us in our understanding of what our graph's going to be. It's going to be the lower half of a circle. So I'll draw my axes. X-axis a little high, so I got room to reach below. And maybe I'll label squared, negative 1, negative 2, so I'll make a scale of 2 squares a unit, so negative 1, negative 2, like so. So I want a circle centered at the origin of radius 2, but the lower half is what I have for my graph of g, because this minus sign in front of the square root sign is an indication that all the y values for points on g will be less than or equal to 0. Endpoints included. The domain of g is square bracket negative 2 comma 2 square bracket. The range of g, now here because y values are negative, it's going to be square bracket negative 2 comma 0 square bracket. This was my x, my y-axis. So there's a graph of g, lower half of a circle. Number 10 was the upper half of a circle. Now let's see if we can take this a little bit further and draw a couple more graphs of transformations of these half circle functions. And in number 12, if we might recognize that we got an upper half of a circle here. Radius is going to be 3. That 9 is like the square of the radius. And upper half of circle radius 3 with center at 0, 0. That's what that square root form is telling me. And then the plus 4 on the end is a vertical shift of up 4 units. So if I were to graph that, it's still going to be a half circle, but it's going to be raised up a bit. So I want 1, 2, 3, -1, -2, -3. Now the original half circle would have been in a position kind of like so. I'm trying not to fill that in too much because we have to shift upward by 4 units. So this original y-intercept at 3 is going to go up to 4, 5, 6, 7, up to here. These original x-intercepts, 1, 2, 3, 4, will go up to here. 1, 2, 3, 4, up 4 to here. So that entire half of a circle is shifted upward. This is the point 3, 4. This is the point -3, 4. And I guess this is the point 0, 7. That's what the graph of this function h looks like. It's just, again, half a circle, but lifted up 4 units above the x-axis. We got one more. And this is maybe the trickiest one of all, this k of x function. Can you see that because I have this x minus 4 inside parentheses, that's signaling a horizontal shift of 4 units to the right, right? Because minus sign means we're going to the right. This is similar to, or maybe I should say the parent graph, which would be y equals the square root of 9 minus x squared. So replacing, instead of writing x minus 4 squared, just writing x squared. This helps me see the parent graph before the horizontal shift. So let's see if we can sketch this now. One, two, three. All right, now I'm going to lightly draw the parent graph, which is that upper half circle, radius 3, centered at 0, 0. But to get the graph of k, we got to shift now 4 units to the right. So this point, 1, 2, 3, 4. It's nice having a grid so I can just count squares to move my points over. This point will move over to the right, 1, 2, 3, 4. This point will move over 1, 2, 3, 4. It'll hop over to the other, just to the other side of that y-axis. And my graph of the function I want here is like so. This is at 1, 2, 3, 4, 5, 6, 7. And so I have x-intercepts at 1 and at 7. And then I believe this point is actually 4, 3. So this is 7, 0, 1, 0, and 4, 3 are, again, they're points on my graph of this function k of x. So a little, I mean, if you know how to look at this crazy looking expression for the function in just the right way, it's not too hard to understand what that graph would be, just a horizontal shift of a half circle. And that's it. We're done talking about circles. We move on to another type of curve and next section.